Hi everyone. So today we'll be covering the chapter of bonding. I did cover it briefly in restorative reasons, but over here I'll complete it in complete detail. Okay. So first we'll be starting with acid etching. Okay, acid etching, and then we'll move on to dentin slash enamel bonding agents. Okay, and we'll discuss all the 7 generations of dentin bonding agents. Okay. Now, coming to the first step, why do we need these bonding agents? Okay. So if you remember when we are filling in our restorative reasons in a cavity, so if this is my cavity and if I filled it in with suppose this reason, now what will happen that after polymerization, this entire reason, it will shrink. Okay. So if it shrinks, well, I can't shrink it over here, right? So it will get smaller like this, right? So I need something that will bond with the resin and it will keep it in place. So that will be over here and it will act like an adhesive and it will keep the entire restorative resin in place. I need something that will perform that. So for that, first we developed acid etching. Okay, so what did acid etching do? So if this is my cavity, it will make the walls slightly rough. So it will create like these, I'll show you, it will create something called micro tags. Okay, so micro tags are just indentations or like uh, deep structures that will where resin will penetrate. So the resin will penetrate in here and it will form mechanical adhesion to the enamel. So that is the first technique we used. Okay, and after forming these micro tags, we needed something that would keep the resin attached like a fevicol to the enamel. So for that we needed an adhesive. So first we would do the acid etching. Okay, first we would do the acid etching, um, and then we will apply an adhesive over here. So if this was the adhesive, we will apply an adhesive over here and then we will fill in the restorative resin. So that was the initial procedure. But there was another problem with this, that the adhesive uh, was not very good with bonding with the dentin. Okay, so the adhesive wanted well with the enamel. It was good at binding the enamel with the restorative resin, okay, but it was not good at binding the dentin with the restorative. Why so? Because the dentin was moist. Okay, so the dentin was a moist structure and it had tubules. So it was somewhat of a hollow structure. Okay, so the dentin has a structure like this. So whenever you are making a cavity, the cavity like all the deposits would come in and it will get stuck in here inside the tubules of the dentin. So in order to increase the bonding, you would have to remove this. Okay, so this is called as smear layer. Okay, so you will have to remove this and then you need something that can bind a hydrophilic substance. Okay, so the dentin over here is hydrophilic. So you would need something that can bind a hydrophilic uh, structure to a hydrophobic structure. That was the reason, right? So until now, we had two things that we were using. First, we were acid etching. Okay, first we were acid etching and then we were applying the adhesive. But what we learned was adhesive was not good enough for dentin. So we started using a new substance that was called the primer. Okay, so the third thing that came in was the primer. So what did they do? I told you that the acid etching, the etchant, it is an acid which selectively dissolves the tooth structure to provide retention. Okay, so it was dissolving the tooth structure and providing interlocking between the enamel and the adhesive or the restorative resin. Okay, uh, this is also known as conditioners and it is 37% phosphoric acid mainly. Now, the second component we are using now is the primer. What does the primer do? Okay, so remember we started using primer when we couldn't bond the resin with the dentin. So the primer came in to help facilitate the bond between the dentin and the restorative resin. So it was doing the hydrophilic bonding. Okay, so it is hydrophilic and it penetrates the moist tooth structure, that is the dentine, because dentine has dentinal fluid. Okay, so it is a moist structure, and then it gets into the mesh. No, the mesh, I'll go over that later on. Basically, it penetrates into the dentine and it allows a connection between the tooth structure and the adhesive. Okay, and the solvent use are acetone, ethanol, or water. So I'll talk about this more in detail. Okay, so basically you have the dentine, dentinal tubules. Okay, and you have a mesh of collagen on top of this. So the primer would basically get into this mesh and it will provide a good interlocking between the dentine and the resin. Okay, and then we had the third structure, that was the adhesive. Okay, so what did the adhesive do? It is hydrophobic, so that's why it was unable to bond with the dentine. Okay, and being hydrophobic, they do not wet the tooth, so it can cause poor air entrapment and air inhibition and poor bonding. Okay, but they did provide a significant bond strength and it bonds the resin to the primer, which thus penetrates and bind to the tooth structures, completing the bonding sequence. So what we learned was that the adhesive is not excellent at binding. So adhesive bonds with the primer. So the image would look something like this. Okay, if I just clear it up. So here I have the my tooth structure. Okay, I have my tooth structure and I have etched the enamel. So I have these micro tags and micro porosities forming. This is my cavity margin. Now I have this adhesive. So of course I'll have my restorative resin first, right? So here is my resin waiting to be bonded with the enamel over here. Just don't look at this side right now, just look over here. So here is my resin, and then I applied an adhesive in the hopes that it would bond with the enamel. Okay, but the adhesive is now hydrophobic, so it is unable to bond with my enamel and mainly dentine. So the adhesive will need the help of a primer that is hydrophilic, and this primer will help in bonding the adhesive with the enamel and the dentine. So this is the entire sequence of how the bonding is going on. Okay, now coming on to the acid etching. So what is the mineral composition and everything? So it is mineralic acid. Okay, mainly it is 37% phosphoric acid. And this is the basic composition. Now how it works? So first it creates micro porosities by selective dissolution of enamel. So what it means is that over here, it will create like small, this is not a small gap. So it will create small porosities within the enamel. Okay, so like this, it will dissolve this much of enamel and it will create small porosities. This is called microporosities. Some of them might be big, some of them might be small. Okay, so it creates these porosities, and what happens is when resin gets into there, it forms something called resin tag. Okay, so the resin will penetrate into these porosities and it will provide mechanical adhesion between the resin and the enamel, and it will be called micro tags or macro tags. Okay, then it increases the surface area of the enamel. So higher surface area, obviously this increases the surface area. So higher surface area means higher surface energy, which means better bonding. Okay, and then the resin tags I told you about, they provide mechanical bond to the enamel. This acid etching also works on the dentine. So previously we used to believe that it did not work on the dentine, it can harm the pulp, but that is not very much true. It does two things with the dentine. Okay, so the dentine has a moist structure. Dentine has a structure like this. If this is my cavity margin, so dentine will have a structure like this because dentine is basically tubules. Okay, so it will clear up the smear layer from here. So smear layer is anything, the dust that will be formed when I'm making a cavity. So acid etching will just remove all that dust from the um, interface of the dentinal tubules. Okay, so it will clear the dentinal tubules up, and secondly, it will provide that microporosity effect on the dentine as well. Not too much, but slight effect. Okay, now coming to the procedure of acid etching. So what happens is first the tooth is cleaned and it is polished with pumice before etching. Okay, Then phosphoric acid is applied onto the enamel and dentine for 15 seconds. So you apply the etchant and then you wash it off after you wash it off for 15 seconds. Okay. You keep it for 15 seconds and then you keep washing it for 15 seconds. Okay. Then some teeth, so primary tooth and teeth with high fluoride content, they require longer etching. So they require longer than 15 seconds. Okay. Then enamel is dried using compressed air because for the application of adhesive and restorative resin, we need a dry tooth structure. Okay. And saliva and blood can prevent effective resin tap formation. So we don't want any moist structures. Avoid desiccation of dentine. So desiccation means drying too much. So we don't want too dry because what will happen is collapse of collagen mesh, which is essential for hybrid layer formation. So what is collagen mesh? I was talking about this. If you look at the dentinal structure, right? So if this is my cavity, right? If this is my cavity and you look over here, this will look something like this. If I make it horizontal, right? If you look at turn it 90 degrees and you look over here, so this is my dentinal tubule that got etched because of the acid. So it formed this resin tag, right? And then I have these mesh. So these are basically collagen fibers that are present on my dentine. This is my mineralized dentine. This is demineralized dentine, and this is the exposed collagen network. So what happened that when I applied an adhesive layer on my dentine, so over here, if you look over here, when I applied a layer of adhesive over here, this adhesive got into the collision layer. Okay, it got incorporated into the collision layer, and this and also got into this empty dentinal tubule, and this formed the hybrid layer. Okay, so this is how the bonding with the dentin takes place. Okay, now coming on to the enamel bonding agents. So enamel bonding agents were used previously. Now we use enamel or dentine bonding agents. So we just have one bonding agent that binds with both enamel and dentine. But this is an outdated outdated bonding agent. Okay. So they were the earliest bond agents and they were more viscous. They were used because more viscous composites did not bond well to the etched enamel. So whenever we had more viscous restorative resin, they will help penetration of the resin into the enamel. Okay, so into the enamel margin. So the resin when they would be used when the resin was very viscous. Okay. The enamel bonding agent help improve the bond by flowing into the microporosities, okay, of the enamel and creating mechanical retention. Now, composition, they are basically unfilled resins, okay, and the main materials, these materials have been replaced by agents that bond to both enamel and dentin. So we don't use them anymore. The bond strength they provided was good. It was nearly 16 megapascals, so which is actually very good. Now, but the problem with them was that they didn't bond, they couldn't be used on dentine. So now we use something that would be used on both enamel and dentine. Okay. So with creating something for dentine was more difficult. Okay, because enamel was a dry structure and our restorative resin is also hydrophobic. So they could bond. But when we are developing an adhesive for dentine and restorative resins. So we need one part of the adhesive that will be hydrophilic, okay, and it would bond to the dentine. And we want one part that would be hydrophobic and it would bond to the restorative resin. So this is the major challenge faced while developing the bonding agent. So we need an agent that bonds both to enamel and dentine, and adherence to dentine is more difficult. Why? Because it is heterogeneous, so the structure is not uniform. It has like this porous kind of structure. It has high water content, which interferes with the bonding, and the tubular nature provides variable area. Okay. Then there is the presence of a smear layer. So smear layer is the debris of the cavity preparation. So this would mean that this dentinal area would be covered with all the enamel and dentin. So we also need something that would clean it up. Okay. So acid etching does that mainly, but it is also a problem. Okay. Then restorative resins are hydrophobic. So I talked about this that we need something that will have one end that is hydrophilic and one end that is hydrophobic. Okay. then supplied. So the dentin and bonding agents dentin and enamel bonding agents we use now, they are supplied in one or more bottles containing etchant and adhesive. So we'll see how many. So different generations have different mode of supply. We'll talk about that. Okay. Looking talking about the smear layer. So just to give you a clear picture, this is my dentin. Okay, and this is my dentinal tubule. So whenever you're creating a cavity, you are doing cavity preparation, all the enamel and dentin debris, it would get collected over your dentin and it can kind of get stuck in the dentinal tubules because it is porous structure. Okay, so your debris would get stuck in here. So acid etching will clean it up and it will remove most of the smear layer, and then you can apply an adhesive, and only after the smear layer is cleaned up, the adhesive will penetrate into the dentinal tubules and provide the desired bonding. Okay. Now coming to the generations of dentin bonding agents. Okay, dentin bonding agents. So the first generation. So remember the first step we were doing, we did enamel etching. The second step, we are not doing dentin etching. Okay, right now we are only etching the enamel in the first generation. This is the oldest because we thought at that time that etching the dentin could harm the pulp. Okay, so we were not etching the dentin. Now uh, we had a bifunctional molecule for as an adhesive, that was glycophosphoric dimethylacrylate. The disadvantage of this agent was that the bond strength was very low. Okay, so it had very low bond strength. Now comes in the second generation. So it used NPG-GMA instead of just glycophosphoric acid, right? This NPG bonded to the calcium of the tooth by chelation. The bond strength was better over here, but the bond strength was still low and the adhesion was short term. Okay, so it would eventually break. Now coming to the third generation. So now in the third generation, we actually tried removing the dentin layer because until now we have low bond strength. So one of the reasons of low bond strength could be that we are not actually bonding to the dentin. And why we are not bonding to the dentin? Because we have a layer of basically debris present over the dentin. So we need to remove that. So over here, we tried dealing with the smear layer. So it was believed that it prevented proper bonding, yet protect the pulp. So people were very confused to like keep it or remove the smear layer, right? So over here, what we did was we did etching of the enamel. Okay, the first step was normal as before, first and second generation. Then we did conditioning of the dentin using mild acids. So it was basically like a baby form of etching. So we did etching of the dentin, but using mild acids. Okay. Then we applied a primer. So a primer was a hydrophobic adhesive that would help bond the dentin with the adhesive. Okay, and then application of polymerizable monomer and placement of the resin. Okay, so we applied the primer, then we applied the adhesive, and then we applied the restorative resin. So it had in total four steps. Okay, five steps. So first we were doing the etching. Secondly, we were doing the slight etching of the dentin. Then we were applying a primer, then we were applying the adhesive, and then we were filling in the restorative resin. So it was very technique sensitive. Okay, we had a lot of steps. This one did tackle the problem of smear layer and bonding with the dentin, but it had a lot of steps. So also in the next generation, we tried to work on that. Okay. Why did we need primer? So I talked about this because why do we need a separate primer? Because the dentin is wet and everything. Okay, then coming to the fourth generation, what happened in this generation? That total etch technique was developed. So by now, by coming to the fourth generation, we were convinced that now, okay, we can etch the dentin. Okay, this won't cause any harm to the pulp. We can actually etch the dentin using the acid etchant. Okay, so here we tried tackling the hybrid layer. We tried developing the hybrid layer. Okay, so what is the hybrid layer? A hybrid layer is defined as the structure formed in the dental hard tissue, enamel, dentin, and cementum by demineralization of surface and subsurface followed by infiltration of monomers into the collagen mesh. Okay, So this is the formal definitions, but what this is basically saying that until now, we were basically acid etching and everything, and we were not actually doing much of the work with the dentin. In the third generation, we kind of started working with the dentin. Now we are sure that we can etch the dentin, so we would create microporosities all over here. Okay, so this is called total etch, etching the enamel and the dentin. Okay, and then we started developing something called hybrid layer. So I told you what hybrid layer was. Okay, hybrid layer is basically when we have this dentinal tubules and we have a mesh of collagen over it, and when the adhesive penetrates this collagen mesh and kind of into the dentinal tubules, this forms the hybrid layer. Now, this hybrid layer helps in the bonding between the adhesive we apply and the restorative resin. Okay, so this is the basic, this is the main component that will enable the bonding and this will increase the bond strength. So here the idea of wet bonding was incorporated. So this is wet bonding, bonding of the dentine and using a hydrophilic substance. Okay. Now the substance we are using, so it included two primers, unfilled adhesive resins. Okay. So first we are doing total etching, then we are applying primer, okay, and then we are applying the adhesive. So one of the steps have been removed, so now we are not doing this mild conditioning. Okay, so until now we had 5 steps. Now in the fourth generation we have 4 steps, and then we are filling in the restorative resin. Okay, so we have removed one of the steps. Now, this system also helps in bonding of the casting alloy and everything to the tooth structure. Okay, so this bonding agent helps in that as well. Now, coming to the fifth generation. Until now, even if, though we have removed one step and we have achieved a significant bond strength, we want more improvement. Okay, so something combined. So in the fifth generation, we combined the primer and the adhesive. Okay, so self-priming adhesives were formed. So we had even lesser steps. Now we had acid etching. Then we did not need to apply primer and adhesive separately. Okay, we had one this self-priming adhesive, and we would just fill in the restorative resin. But this had one yeah, so we would just do that, and then the advantages are it reduced the application steps, it was less technique sensitive, the liquid was less volatile, it has pleasant odor and higher bond strength. Okay, so this provided better bond strength than the other methods. Now coming on to the sixth generation, we are still experimenting, trying to develop something better. Okay, so we have again 2 steps. So in the we have 2 steps in this one as well, and we have 2 types. So in the first type, we combine the etchant and the primer. Okay, we combine these 2 steps, and then we had a separate adhesive. And in type 2, we have a separate primer, and then we have self-etching adhesive. So we would prime and then we would have a self-etching adhesive. But there is a, if you think about it, that both of them aren't very good, because in either of the cases, you're not washing off the smear layer. Right, you are applying a liquid and then you're keeping it there, and then you are applying another liquid on your surface. Okay, so you are not actually washing off the smear layer, that is the debris formed over your cavity margin. Okay, so we need to wash this layer off, and that is not happening in here. This would actually have lesser bond strength than the fifth generation. Okay, and in the seventh generation, we tried combining all 3 steps, so the etchant, the primer, and the adhesive into one, but none of the products have been extremely successful. Okay, so this is it for bonding. This was not a very big topic. I hope you like it. Thank you.